Hello everyone, thank you all for coming. I'm Alex, this is Martin, and we're going to talk to you about TRAC, which is a new and modern way of managing something that we call structural analytics. Other people might think of it in the realm of regulated calculations. Actually, what's really going to happen is Martin is going to talk about TRAC, give a demo, and explain the pattern and how it works. And I'm going to spend the first 10 or 15 minutes trying to convince you that there is such a thing as structural analytics, and that the way banks have traditionally built platforms to support this kind of activity is somewhat flawed. There's obviously many ways that you can think about and characterize analytics and analytic technology. For the purposes of this discussion, I think it's useful to think of the entire universe of analytics as being split by the basic mode in which you're operating. And I'm going to argue that there are fundamentally three analytic modes. The first is generative. So you're using machine learning AI to generate novel outputs from defined data inputs. The kind of technology solutions that are being built in this space prioritize things like scalability, the ability to automate data pipelines, and the model training process. There are lots of sessions today talking about these kinds of technologies. Then you have exploratory analytics, where you're looking to identify, explore, analyze patterns in data. This tends to be a supervised process led by people, but is necessarily flexible. You go where the data takes you. And the technologies that you need for this kind of analytics have to prioritize things like flexibility, interactivity, the ability to prototype quickly. Now, I would argue that when people talk about the discipline of data science, they're generally talking about the combination of these two things. And there are a vast number of very mature enterprise-grade technologies that allow you to do this kind of analytics agnostic of the use case or the business domain. This talk is about the third mode of analytics, which we call structural analytics. This is where you are applying complex but predefined and relatively stable analytics to data sets to generate outputs that have a structure and meaning that's known in advance. Financial service is full of structural analytics. If you think of regulatory capital calculations, credit provisioning models, liquidity calculations, balance sheet modeling, you're effectively taking a semi-rigid, complex analytical process and applying it to data. Now, unlike these two modes of analytics, the thing that's really important when you're doing structural analytics is control, resilience, transparency, auditability of the process. Fundamentally, it's about being able to prove that what comes out of the process is fully compliant with all of the governance requirements that are applied to that particular use case. Now, if you think about how technology is traditionally provisioned for these kinds of analytics, people often talk about a choice between buying an application, which has some of the business logic built in, data model, calculation structure, model components, or building an application using a more foundational technology. Make Python models run in the cloud, for example. And these are fundamentally different, but we would argue that almost every example of both of these methods use the same approach to create the control environment. So you take your current in-governance version of a model and its calibration and configuration, and you build a physical deployment of that in an application, and onto that application you apply access and change controls. You effectively freeze it. So the traditional way of building platforms for these kinds of regulated analytics is to create solutions that are specialized. So it supports one type of model, one family of models. They're stateless in the sense that you can use the platform to generate numbers based on the latest version of the model or calculation. Typically very hard, if not impossible, to recover prior versions, prior states of the deployment. And they're closed in the sense that only a few people are allowed to access the application. And they're closed by necessity, because if you have a stateless solution, the one thing you can't afford is accidental or unauthorized changes being made. Now, obviously I can't say that this approach to building analytics platforms doesn't work, because pretty much every institution's been doing it for 20 years. But in almost every bank that I've ever seen, you face the same 4 challenges when it comes to these use cases and the technologies supporting these use cases. So it's almost always slow, difficult, expensive to update production. Your business teams tend to be reliant on a suite of offline tools and emulators that basically replicate what happens in production, but allow them to do analytics and exploratory calculations that they can't do in production. The control environment is based on a large amount of manual processing, data reconciliation, writing documentation, filling in audit reports, signing attestations to prove that what's being calculated is in line with what was signed off in governance. And then you end up with silos where different classes of model end up being supported using different technical solutions and different operating models. And I'm going to argue that these 4 problems that almost every institution faces are an inevitable result of the way that traditionally this technology has been built. So, TRAC, which is the solution that Martin's going to demo and explain in a minute, takes a new approach. So TRAC creates an environment which is universal, stateful, and self-describing. Now, it's probably a little bit abstract. What that means in practice is the platform allows you to automate the route to live. So pretty much any type of model can be promoted from development to production with just a few clicks. You can then combine models to create complicated execution patterns in minutes. As you go through the process of building those patterns and then using them for calculations, the platform will create all of the documentation that you need from a governance perspective automatically. You don't have to write any paper documentation at all. That the versioning system that sits behind TRAC is so strong that you can entirely safely allow people to use the production environment, production model code, production data for experimentation and analytics. So you don't need that suite of offline tools and emulators that the business teams maintain. And finally, that any calculation you've run on the platform, even if it was 5 years ago, can be replicated in full with a few clicks, and you will get the same result as the first time you ran it, guaranteed. So it's, in a sense, the most auditable way you could build a platform for analytics. With that in mind, I'm going to hand over, and Martin will give a quick demo of those capabilities and then explain how the pattern works.
Hey, hello. I'm going to very quickly show a demo of what TRAC looks like to use. So this is what I'm going to show you today is available as a community edition of TRAC. You can download and try it out. So I'd like to go through that and then talk a little bit about kind of the pattern, the TRAC architecture, and how you can use that pattern maybe in other data analytics platforms, and what components are also available under the from FINOS as open source components. Hopefully this is big enough to see. There we go. So what I'm going to show you is just how we can load in a model, build a calculation workflow, and run it. And that's going to take just a few minutes. I think those of us used to doing that in real-world situations are more used to taking sort of maybe months to do that kind of work. So let's go to this load a model screen. So here TRAC is connected into GitHub. So we've done a lot of work to integrate TRAC with various different model and data technologies. So that's kind of all pre-done. And you can see we've got access here to my GitHub profile. We can see all the branches that are available in this repo. We can see releases, we can see tags, etc. So you might decide what you want to make available in TRAC. You probably don't want to have like unprotected branches available, for example, to a production system. But the point is that this is not a technology barrier. This is a policy barrier that you can decide. The technology will let you do kind of what you want to do. So I'm going to select this latest commit, and we can browse now and see what's in the repo. We've got some demo models here for impairment. So I'm going to load this impairment model. And that's it. That's all we need to do to select that model. You can see TRAC has found a bunch of metadata about this model. So it knows where it is in Git. It knows how to run it. We've got some keys and descriptions that we've put as annotations in the repo. And I'll show you in a second how that's done. Essentially, we're pushing that responsibility onto the modelers to say, what does their model do? So the platform knows when that is loaded up. And that is it. I'm going to say import model, which will take a couple of seconds. And there we go. So that is how easy it is to bring a model into the platform. And that's possible because we've separated the model code from the technology components. So I'm now just going to have a look for that job. So you can see here is a job that I've just run. We can have a look at it so we can see that it was run just now. We've got some information about the job, and we can see the model that was created. So we've got a bunch of metadata about this model, and TRAC records this metadata automatically for everything that's in the platform. So you don't need to do any work to go and gather this. It's all just captured as part of setting up your process. We've got a PDF report. So if you want to send that to your model governance team, that's all pre-generated. You don't need to write it. And we've also got a link to the model code. So TRAC knows that this is the model that I've just imported, and that's the exact version of the code. So if you load another version later, it's not going to get confused as to what version you're running, and you can always link back and see exactly what you've run. So that is importing a model, and now we want to build a process. So let's say build a flow. Oh, let's run a flow, sorry. It is build a flow. Okay. So we're going to select some models to put into this flow, and we've got some filtering here so we can find what we want to find, and you can set that up with whatever business vocabulary you want. That's entirely configurable. We've just done this for the demo. So I've selected these 5 models. And what TRAC has done is it's looked at the metadata for those models and assembled them into a calculation process for me. And we've got a representation of that process here. So the orange boxes are data inputs, the black boxes are the 5 models we just selected, and the blue boxes are outputs. And you can have, if you don't need to save all the intermediates, you can do that as well. So you can edit this, you can play around with it if it's not kind of quite how you want it. But in this case, I'm just going to save this as demo impairment flow. There we go. And let's say upload a flow. And that's it. We've created a process based on those 5 models. So again, super easy to do. And the last thing I want to do is run that quickly. So let's say run a flow. Again, you can set up what sort of filtering and conditions you want for what's available. So here TRAC has gone and found all the data inputs for this flow. So it's done that by looking at the metadata associated with those data sets, so it knows which ones are sort of viable inputs for that flow. It also knows what parameters are needed. So based on the models, it can say what are all the parameters and build this interface for us. Yes, sorry.
Sorry to interrupt, very quick question. The metadata, where are they found?
So TRAC has its own metadata store that captures metadata for all of the different object types, models, datas, jobs, etc. And we bring that metadata in as assets are added to the platform. So when you import a model, TRAC creates the metadata record for that model. And that's a key difference between TRAC and I suppose other metadata platforms is typically the metadata is added sort of on top of your assets, whereas in TRAC it's the foundation that everything is built on. So the metadata is your calculation instruction, it is your audit record, so that guarantees that it's always going to be correct. And I'll show you in a second what it looks like to annotate a model with that metadata, so you can see kind of where it gets it from.
Yep. It's going to be inarticulate, unfortunately. So normally we have a model that is expecting an input handlers and breaks an output handler. And it can be able to string those models together. So there must be they must know of each other. Okay, does that mean, so when you're coding your model, which is further downstream, they must know some knowledge of the other output handlers in which to want to create it. So that seems an awful lot of the work. I think it's brilliant, but what is the work or onus on the model developer to be knowledgeable of what these other handlers are doing?
So
apologies for not.
Sorry, it's okay. We can jump around. So here's an example of a TRAC model that's been, we call it wrapping. So the model code in run model, you can basically do whatever you want. And in TRAC, you don't really do any of the sort of data preparation or loading. So the model just says, give me my scenario input, or give me my customer accounts input, or whatever it is. And you define a schema for those inputs and outputs. So you can see the define inputs, define outputs functions there. Those schemas are just CSVs with the fields and types. So now we're able to generate from this a metadata record that says this model needs these inputs, these are the fields that it needs to have, these are the conditions on them, whether they're nullable and so on. And that allows TRAC to know which models can be strung together and also what inputs and outputs are going to be suitable for a job.
So on the flow builder page, when it constructed the flow, that's by matching the declared inputs and outputs of the models. If you've got teams that use inconsistent naming conventions, you can manually rewire it. So it will put it together based on all the matches. If you know that there's a slight inconsistent naming convention, you can manually rewire it. But if you have good naming conventions in the individual model schemas, it will all work automatically.
So, sorry, one last question too. That requires a sort of like a data architect or to define find that before you instruct the modelers?
So the modelers can put what they like in here. Now obviously you need to, when you're designing your process, think about what that schema should be, but it's not a technical constraint. So there's no database tables or anything like that, that when you load this model, there's technical work needs to happen on the back end. TRAC will let you load in whatever shape you want, and it will put that together for you. Does that answer your question?
I think yes.
Okay. So the other advantage of this is it also acts as a control point. So one of the things we typically see in a lot of model code is there's a lot of top and tailing of preparing the data, dealing with things like data that's badly formatted, nulls that aren't expected, date formats, etc. So TRAC will do all of that for you. You can see in this code, we're literally saying, give me my table. All the data preparation is checked. So you know that what you get when you run this in the IDE is going to be the same format that you get when you run this on the platform. And there's not going to be sort of any surprises. So that, again, allows us to sort of take the code from the desktop and load it into the platform without the long process of fixing those data issues that you'd normally encounter. So, yes, let's run this flow. So here we've got a screen. This is telling us everything that it's going to run. And just to illustrate kind of the metadata point, we've got information about each of these items. So this is a model. You can see all of the information again. You've got the link again to the source code if you want it. The same thing for all of the data. So we've got information about these data sets, when they were loaded. If they were created by another TRAC job, then that information is available, so you can sort of go back through the graph. We can see the data here in the UI, so we can step through this if we want to. You can also download it. And I'm just put in some information. And you can assign some classifications. Again, you can set those up kind of for whatever you need. And now if we go to the jobs page, we should be able to see that. And this is just obviously some demo data, but now we've got all of this information again. We've got access to the logs if we want to see the log of the run, so you can sort of use that as a debugging tool. We've got all the metadata again, and now we've obviously got the outputs because we've run the job. We've also got a visual output here, so we can download that if you want to have a look at it. Some fairly noisy data. And we've got a report. So where we talked about the automatic documentation, we can produce this automatically. This is everything that's gone into the job, the process graph again, and all of these links for the data and model assets. So we can click these, go back to the platform. Now we've got the model record, and we can go through to the code. So that is, I suppose, what it can what it can look like if you sort of follow that pattern. So that is TRAC. I think in the interests of time, I might just move on to the patterns and components. Okay, so TRAC is, I suppose, in essence, an orchestration layer. So we've tried to sort of not build new things, but rather use common technologies and patterns and let people sort of have access to those. And TRAC is sort of the missing layer, I suppose, that sits over the top and does that orchestration for you. So it's completely technology agnostic. So it'll run on top of any of the major clouds or on-premise. All of those sort of integration points are abstracted. And there's a few kind of components that I think are probably interesting. So the first one is the runtime. So this actually, we know there's a few organizations that have taken this component and used it in their own platforms. So this provides a way of executing model code and separating the model code from the host framework. So it handles the loading of that code, virtualization of different sort of code sources and repositories. Also in Python you can have sort of namespace clashes, so it virtualizes the model namespace when it's loaded to solve that problem. And it also provides the data conformance piece. So that's something that you can very easily write models in, run them on the desktop, and then run it either as a sort of a single batch process from the command line, or integrate it into a platform, and there's APIs for doing that. So we know that people are doing that. So that's good. The other parts, I suppose, are the metadata models. I think this is one of the key differences between TRAC and other platforms in this space that we've seen, is that it's built on the metadata as the foundation. So it's quite common, I think we've seen in a lot of organizations, to have metadata associated with data sets. Obviously your code is all going to be versioned. A lot of places would use like Calibra or some sort of downstream metadata collection. I think one of the patterns that we found really helpful was to use that metadata as the foundation and to bring it into a central place, so that we don't need to go and talk to all those different components in order to build kind of the information about a job or the history of where data has come from and so on. The virtual deployment method we've seen, I think that's kind of a consequence of having all of the assets available as metadata, is that you can do that kind of construction just from those metadata elements, which avoids the need to do a physical deployment. And the last part, I suppose, which is quite key, is the immutable assets. So when we looked at that job report, obviously we'd just run it and that information was available, but you can go back in sort of, a year later or 5 years later, and that's still going to be there. One thing we didn't actually look at is there's a rerun button on the bottom of that job, so that will pick up those same assets and run exactly the same calculation again. And because we've guaranteed that the models and the data are immutable, we know we're creating the same calculation. What that lets you do is sort of step in if you need to see, how has my position changed from last year to this year. You can sort of start from last year's position, step in changes, and create that waterfall very easily. Yes, I think that's it. Just the last thing then is how TRAC is available. So the TRAC runtime, I think I mentioned, is available. It's entirely open source. It's available on PyPy. Source code is available through FINOS as well. So you can use it, and we know that people are using that as a component of sort of other analytic platforms. You don't have to run it through TRAC. The core TRAC services are also available through FINOS, so you can take those and extend them. They're designed to be sort of built on top of, but perhaps more realistically they can be used as a reference to what sort of building a platform around some of these patterns can look like. And then the last part obviously is that we have the TRAC professional product, which is available on a commercial basis. So, yeah, I think that is it. Any more questions?
So we can go back to my original
No,
question.
please.
By metadata, you don't refer like to parameters, like the ones we saw in your example.
So you're talking about sort of like parameters for a job or model parameters?
Yes, like, so as to calculate my LGD, I need this input, blah, blah, blah. Is this part of your metadata that's already preloaded, or it's something?
So when you saw it in the IDE, schema of the model, which would be its inputs, its parameters, and its outputs, is expressed there. When the model's loaded, part of the metadata record for the model is then the inputs, the outputs, and the parameters, or the data schema of the model.
And this already preloaded by you somehow?
No, it's the user creates it. When they create the model, they express those the model schema in the code using a custom function, and then when you import the model to the platform knows how to use that model in a process flow.
Okay,
It's quite a lot of different options as well. So you could create, for example, a parameters data set, which could be tabular, or you could have sort of structured data, or you could have calibrations. So those things you could create and save in the platform as parameters as well.
So the metadata, right? So does it also help you, in terms of giving a data lineage kind of thing where your data moves?
Absolutely, yes. So that job record that we put up has got all the information about every data set in a job, so inputs and outputs. That's also tagged on every asset in the platform, and then you can trace that back. So you can start from, okay, this data set was created by this forecasting job. Maybe before that you had some other stages. If you've got data preparation on the platform as well, then you can trace back essentially all the way to where data is ingested, and then that will be linked to, okay, it's come from this system. So yes, you've got that sort of complete lineage built in.
So in a graphical representation where, like you had this click of a button where you open the code base. Do you have something like that, or it would be saved in the database?
Not today.
Not yet,
As a
no.
graphical representation, but it's on the roadmap.
So for each job, it will be contained. You saw the governance report.
Okay.
If you have data where jobs have fed into jobs, we don't yet have the lineage tree graphically represented, but the information's there. We just haven't built that screen yet.
Thank you.
I think we're at time. Thank
Okay.
you very much.
Thank you.